Suddenly, now we're looking at a problem where the bases are not the same. This is still a one-to-one property problem. However, we need to get those bases to match first. No big deal if you remember this table. It's coming back again in this chapter. However, if you don't still have yours, raise a hand. I have about 100 lying around. Just let me know. 36 is the same thing as 6 squared. So we can rewrite the number 36 as a 6 squared. I'm not doing anything on the left. We're just talking about the right-hand side here. 36 is the same thing as 6 squared. Note that now my bases match, so I can use that one-to-one property. If the bases match, then the exponents are equal. And suddenly, just like the last video, the algebra here becomes fairly simple. This is algebra 1. To get rid of a minus 10, we add 10. Do something to one side of an equation, you need to do it to the other. So we wind up with 2x equals 12. I don't want 2x, I just want 1x. So dividing both sides by 2 will get me that x is 6. You can always substitute that 6 back into the original to double check that you did this correctly. Note that if x is 6, well, 2 times 6 is going to be 12. 12 minus 10 is 2, so this does check out. Let's look at an example where we're no longer looking at squares. Note my bases are not the same. 2 and 8 are not the same number, but 8 is a power of 2. Same table as last time, but we're jumping over to a different column. So now we're looking at cubes. So 8 is the same thing as 2 cubed. So I can rewrite this. 2p minus 7 doesn't change, but 8 is the same thing as 2 cubed. Now my bases match. So we're back to the one-to-one property. P minus 7 equals 3. Adding a 7 to both sides will get you that p is 10. Again, it never hurts to go back in, double check that your work is correct here. If p is 10, well, that means 10 minus 7 is 3, 2 cubed is 8. So this solution does work. So even when our bases are not the same, the one-to-one property can really help us out, save us a ton of time here. And our last easy example here, note we have 32 and 2 as our bases. While those are not the same, 32 is the same as 2 to the 5th power. So we can replace that 32 with 2 to the 5th. Didn't change anything on the right. So now we see our common bases. So we can just set those exponents equal with the one-to-one property. So from this we get that 5 is 2m minus 9. And it winds up being a two-step equation. Adding 9 to both sides. Goodbye, 9. 5 plus 9 is 14. And to find a value for m, we can just divide. M will be 7. It is always good practice to go back and double check your work. If m is 7, well, 2 times 7 is 14, minus 9 is 5, 2 to the 5th is 32. So in these examples, we were able to replace a number with one of the powers from our table here, and it made the algebra, not too bad. We do want to kick it up a notch. We'll go ahead and do that in a separate video. See you next time.